So my name is Pierre Baumel, and
Alexander Seitz.
we are both researchers at CIRAD, and we will present our work on Cormas, that is a participatory agent-based platform, and for participatory modeling, and also to create serious game with local stakeholders. Here you have a picture of one game we did in the Amazon forest, in Brazilian Amazon forest. So we both are researchers from CIRAD, and we belong to the Science unit. Science means Savoir, Environnement, Société in French, so knowledge, environment, and societies. And it is a pluridisciplinary unit, mainly in social sciences, economists, anthropologists, etc., but also in biology, agronomy and ecology, and some few people working on modeling and computer science. In this team, we have built for 25 years Cormas, that is an agent-based model platform, in order to help management of natural resources. So some few words about what is an agent-based model. With Cormas, we used to use ABM to simulate socio-ecosystems by crossing different kind of dynamics, natural dynamics, links to climate, etc., but also economic and social dynamics. And in order to better understand how socio-ecosystem may function. So we get the consequences between individual practices and interaction with natural resources dynamics. And from that model, we can also explore various modes of collective organization. So there is plenty of books speaking about this kind of use of ABM. By doing ABM, you will articulate two levels: the micro levels, where you will design your agents, their behavior, their rules, but also, and then from when you have done these jobs, you will simulate and you will see what happened at the macro level. So we speak about emergence, auto-organization, and we will see how group, institution can emerge from simulation and have a feedback on the behavior of the individuals. So this kind of paradigm help us to discuss with sociologists, to illustrate some principle or theory in sociology, like methodological individualism, or at the other side, methodological holism. So we used to use Cormas with visual works, for example, to work with groundwater pollution in Costa Rica. And here you have a photo with a stakeholder, so agriculture, using the platform. But also at the bottom, you have a picture of a simple model, a physical model that explains the movement of the water into the ground. Then we did a small model that explained how can move the water into the ground. Then we did a full game where we can interact with the simulation and see what happened in terms of economics returns, but also in terms of pollution and etc. Okay, so etc. Another example, I work in Amazonian forest in Brazil, and to find alternative farming practices for deforestation. In that case, we identify small-scale farmers and their needs, etc. We design a kind of very simple UML diagram that presents that idea. Then we simulate different kind of strategies to use the environment, and with several kind of initial landscape. I cannot go into the detail. It's just to have another quick overview of what we done. emergence of resources convention between different stakeholders using in England network evolution for water, kind of shift cultivation and creation of a new mosaic of landscape. We work on coffee rust spread in Nicaragua regarding to the altitude, and also the spread of the CBB, so coffee berry borer, in Central America. This kind of things. So the unique Cormas has several features like net logo, like several platforms, but it has some specific features, such as the different point of view. We can see your simulation with different views. You can interact with your simulation due to the live dynamic environment, due to Smalltalk. And you can interact so with the grid, with your agent. You can manipulate your entity, and you can also do and undo some things you did. And you can have the possibility also to come back in time with your simulation. Cormas is based on Smalltalk, and thanks to Smalltalk, it benefits from reflexive language for introspection, to inspect and analyze your object, to intercession, to amend its semantic and behavior. It has a powerful debugger, so it takes the modeler into the heart of his simulation and offer more sensitive vision of the way it operates, and put the modeler himself in the place of the agent. So debugging is a learning process in itself, and I didn't tell that, but Cormas is a platform dedicated for thematicians, people that are geographers, agronomists, and that are not used to create code. So I think that with Smalltalk, they can go very faster into the coding process, and thanks to the debugger. So it's a great language to prototype a model and check if it works well. So Cormas platform is based on several years of field experience, and now, since 5 years ago, we are now it is implemented in Pharo, and thanks to its MIT license, and also due to its dynamic community of researchers. And also Cormas now is well suited for companion modeling, so we will have some words regarding the companion modeling. We call that the commode approach. The commode approach, okay, this is also a kind of participatory modeling. We identify what is the stake, what is the problem in a given socio-ecosystem. Then first, we identify the point of view of the specific stakeholders that are using these resources, natural resources. When we have done this work, we pass to a second phase where we will do a collective building of a shared vision of the system by using a kind of different kind of diagrams and a specific methodology for that. And when we have done that, we can implement the model, and we go into simulation. And the idea is, after that, to modify the representation that the people have on their system in order to consider the constraint of the others using these resources. And maybe we expect changes in practices and even collective decisions. So the idea of the methodology is not to provide ready-to-use solution by the model, but rather to help people to find this solution by themselves through an artifact, a model. We use Cormas for designing with UML, so like object diagrams, like class diagram editor. I did it with Peter Unak, so it is not working anymore because OpenPonk is sleeping. And we have also an activity diagram editor that can help us to modify the decision rules of an agent and execute its behavior immediately. So here you have two photos on the project I did in Uruguay. So on this photo of the left part, you have farmers that are analyzing activity diagrams, and on the right part, a farmer that is explaining a simulation, the result of a simulation. In our team, the main review we are focusing is called JAS, for Journal of Artificial Societies and Social Simulation. So now I let you continue.
So I will continue from there. Thank you, Pierre. I will talk here. So I will give you a very brief introduction into the final topic on which we are working, which is called serious games. So serious games, there are any kind of games that are used for any purpose different than entertainment. So as you can see here in those two pictures, this can be military games for training soldiers on aircraft simulators or some kind of logistical planning. All of these are serious games. In general, we defined 3 kinds of serious games. So as you can see on this picture, the one on this side, it's entertainment. It's not a serious game. It's a regular games. And the other 3 are serious games. So you have games for research, is the kind of games we use to generate data. Then educational games is like flight simulator, so to teach people to do something. And the final part is the games that we actually use in our team. Those are the games for intervention. So these are the games that we use to make people talk, discuss, exchange ideas. And because of that, for us, it's very important to have the functionality of interaction and participation. Here you can see the example of a game that we use. So mostly we engage in role-playing games. So these are the games that where every person in the group gets some role to play. They can act as farmers, as fishermen. They can represent, for example, local authority, and we model certain scenarios with these people. So as you can see here, we have the fully physical, non-computer version of the game on this picture. And the important point that I would like to stress is that games are highly accessible. So something that is different from the computer simulations. When you show computer simulations to many people, they don't know how to work with them, they don't understand them, but everyone can play a game. We can design a game for anyone. Here is an example of one game that was created in our team. It was done in a collaboration with Leaf, which is the startup in Switzerland. This game is called Planet C. Why Planet C? Because there is no Planet B. Yes. So this game is used to model the management of 2 natural resources. So one resource is important for the people, it's a resource that they need to survive, and another resource is they want to protect it, but they don't directly use it. For in our game, usually we use the species of birds. We want to protect them, but we don't eat them. And here in this picture, you can see 2 versions of this game that we have. One version is fully physical, yes, fully physical, where people can play on the board, and another version is fully digital. So when people can play on the smartphone, on the website, it's the same game but 2 different versions. Here is the picture from Senegal. So on this picture you can see the bald guy. It's not me, it's not Pierre, it's Francois. So Francois is using a Planet C serious game as a first stage of modeling in his thesis to understand the practices of people in a village in Senegal. Another game that was developed in our team is called Dukunomole. So it was developed by a colleague who works with us from Sao Tome and Principe. And this game is used to model the biodiversity in a tropical forest. And again, as you can see here, we have 3 different versions of the game. So we have the game that is fully physical, where people play on the board game. This part is the game that is fully automatic, so you can use a computer to play it. Yes, and if I click, you see that it's moving. And in the middle, we have the game that is kind of a hybrid approach. So this is a horizontal projector that can project the output of the game, but the input still has to be entered manually into the computer. So from that you can see that we have different kind of support that we can provide for facilitators of the game. And why do we need to provide the support is because facilitating is sometimes difficult. So when we play a game, the more complex the game becomes, the harder it is to facilitate it. So researchers have to remember many rules, they have to know how to update the situation on the game, and the more difficult situation you want to model, the more hard it is to remember them. That's why we provide different kind of support. The most simple and the most basic support is just to help facilitators using some spreadsheets. So it's the kind of automation that facilitator uses for themselves, but they don't show it to the participants. Another level of automation is when we update the environment. So it's the kind of horizontal projector that you saw in previous picture. Computer can use the calculations to compute the next state. It can output it on the environment, on the board, and then players will be playing the game as usual. But the facilitator still has to enter their actions into the computer. And finally, the biggest kind of automation that we can do is the full automation, where the whole game is implemented into a system, so in our case in Cormas, and then it is used by players to simply play on the phone or on a website or a computer, and facilitator simply observes the session and makes notes. One final thing that I want to say about the games, which is important to understand, is that for us, the most important part of playing the game is the debriefing. So when we play the game, after each session, we talk to people. We try to understand what are they feeling, why they did certain actions. We try to take some notes from how they were doing it and what were their thoughts. So to make the situation of exchange between them. So you can see that here, all of these pictures, the 4 of them, this is the same project that was done stage by stage. In the first stage, they designed a fully physical game. They played it. Then they used it to create the second stage, where they played on the on a table, but it still had this live update through the computer. And finally, the fully automated model that was implemented was Cormas. Yes, and it's moving. And we have a debriefing section in the bottom. So this concludes my section about the games, and now I will quickly present to you the certain challenges that we have with the development of Cormas. So how the Cormas is currently developed. Important thing to understand here is that Cormas, as Pierre mentioned, it is currently developed in Pharo, but it was originally implemented in VisualWorks Smalltalk, which was, I think, 25 years ago or something. So it is currently a legacy system. However, it is not a typical problem of migration, because we are not migrating Cormas directly from one version to another. We are not moving all the same functionality from VisualWorks into Pharo. The thing that happened is, over those 5 years when Cormas was re-implemented in Pharo, it became a completely new version. So we have not Cormas version 1, Cormas version 2, but it's rather, you should think of it as Cormas A, Cormas B. Which means that there are some functionalities that exist in VisualWorks, and we still want to get them in Pharo, but we don't have them. On the other hand, we have many functionalities that exist only in Pharo, and we didn't have them in VisualWorks. Another kind of migration that is happening right now, and this is something that we really hope to finish by September, is the migration of Cormas to Pharo 12. Because the current version of Cormas works on a Pharo 9, and which is currently deprecated, yes. And this is mostly because spec 1. So Pharo version of Cormas was developed on spec 1. A lot of widgets, a lot of windows of Cormas were developed there, and it's really hard to move each one of them to spec 2. So it is also, this process is also slower, because we don't want to put a lot of time to migrate something that we know will be gone. So we want to find out what is the good UI that we want to have, what is the better UI for Cormas. In that we want to be inspired, by the way, by the ideas of Ernan, because he made some really good sketches for the new UI of Cormas, and by Remobidic, because we're really inspired by the UI that they have. And then we will migrate the Cormas UI and have the fully spec 2 version, which will allow us to use Cormas on any modern version of Pharo. Another really important thing for us in the current development of Cormas is reducing the dependencies, because the philosophy is that Cormas should stay as a very simple system. At least the core packages of Cormas, the ones that allow you to define a model, to define agents, it's not such a complicated thing. But the current version has a lot of, well, not the current, because we cut a lot of this already, but let's say some months ago we had a lot of heavy dependencies on Project Framework, Tabular, Grease, Rosal 2, and this made it really hard to load Cormas. So right now what we're doing, we're really cutting all these dependencies and making sure that Cormas can be loaded quickly and that it can be independent from other packages. From that perspective, we are splitting Cormas in 3 separate parts. So we will have a core part of Cormas which allows you to define a model fully in the image without any visualizations. It will have a minimum number of dependencies. You can use it on CI. It should be fully tested as much as possible. So this part we already have it. It's already separated. It's already nice. Now what I'm doing is I'm cleaning this part to remove all the things that are legacy, that are not used, that should be elsewhere. The other part is the visualization. So this part is what allows you to actually see things on the screen. So where we have these circles, cows, cells, all of this is currently implemented in Rosal, and there should be a separate package that is fully independent from the other three and that itself depends on the core package. It would also allow us to replace, when we want, Rosal with Block, or for example other visualization engines that were presented here yesterday and all these days. And finally the UI part. So currently it's implemented in a weird mixture of Spark 1 and Spec 2. Hopefully soon it will be fully Spec 2, but having this nice separation would also allow us to test with different kinds of UI. So maybe we would be able to implement it in Topo. We want to add also a nice support to Cormas. It's the support for games. Why? Because currently Cormas is only an agent-based modeling platform that allows you to make simulations. And but as I mentioned before, in our team we do a lot of games. We make board games, other kind of games. And if you think of it, games are also kind of simulations. Because every player in the game can be seen as an agent that is making some actions, which means that all the same infrastructure that we use for agent-based modeling, we can use the same kind of things to play a game. This means that every model can potentially be played as a game, and every game already is a model. Here, this is a nice slide because we received these pictures just 30 minutes ago. So last year on ESUG, I presented to you the project that we had to develop a hybrid game board where a board would automatically detect the position of pieces and communicate this information to Pharo. And it will be used then by Cormas to update the situation in the model and to combine the physical game board with the digital model. So today we received these pictures. We already have a first prototype that was developed in Senegal by our colleagues. It was originally started by Mohamedou, who was our intern in Montpellier. And when he finished his internship and moved to Brest for his PhD, we moved this project to his home country, to Senegal. And his colleagues from the university, they continued it, and now we have this nice prototype. So I didn't play with it myself yet, so I cannot tell you more, but we will make some nice videos. We will share them with you. So now finally I will tell you about the two interesting challenges that we have in Cormas that we are currently thinking about. First is that we noticed that as we use really nice tools that we have in Pharo, for example debugging tools, sometimes they're not perfectly suited for agent-based modeling. Why? Because if you think about debugging, normally these tools, they were developed to explore very large code bases and a relatively small number of objects. But in modeling we have an opposite situation usually, so it's not always the case, but usually the source code of the model is not that big, there are not so many dependencies inside the model itself, but we deal with a lot of objects that have unpredicted behaviors, that have sometimes random behaviors, and we need to debug and we need to understand these objects individually. That's why we are currently working together with Steven and with other colleagues from Indra. We're trying to see how we can use object-centric debugging and other nice practices to provide nice debugging experience for ABM in Cormas. And finally, another challenge that we are working on is the challenge of testing ABM. Because a very good practice of test-driven development or writing unit tests is often discarded in modeling community, especially in companion modeling community, because as you can see on this graph, when we write tests, the trade-off comes later in the project lifecycle. The trade-off is very, very important. We get a lot of benefit from writing tests, but when we write model, especially when we do it in the field together with people, this first part of developing the model is the most critical. And it is often not possible for the modelers to invest a lot of time to create tests in this point of modeling. That's why we need to look at some other techniques or some other practices that we can provide, that we can propose to modelers to still test their models. For example, by generating tests through traces. So this is the project that is currently implemented by Gabriel in Armod, and we're really interested to see where it goes because it could be very useful for Cormas. So this sums up, this is the summary of our current development stages, but because we are out of time, I will just skip to the final slide. Thank you very much. Questions?
So I have two. The first one is related with the, let's say, utility of the negotiation capability that you give to the communities. How that is used after the research has ended. I think that, for example, this will be pretty useful for activists in advocating for public policy, for example. So what is the scale, the temporal scale of the capability that you build into the communities? And the second one is related with the testability, because also in data storytelling, data journalism, or hacktivism, test-driven development doesn't happen. The people start with a story, and this idea of trace-based development can be pretty useful there. So how can you think about like this, let's say, cross-pollination between different fields beyond modeling or agent modeling? Like, what would be like? Yeah, maybe it's one. Yeah.
I can start. So for your first question, it's not easy to answer. I have experimented several projects with local. We used to work with local people at small scale. In some project, it was just an échec, a failure, and in some cases, a big success. So it's not something very deterministic, and it's hard for us to understand why it was a failure and why it was a success. But I hope we have more and more success in that kind of experiment. Success, I mean that after the project, the dynamic, the social dynamic is continuing, and we have concrete results in the field and in the politics at the political level also. My best success story is in Uruguay, working on adaptation to climate change for the bovine breeders, and now all the stuff we did it at the level of the government that they want to apply it at the level of the country. But also I have a lot of failures. So.
Yes. And for the second question, so the second question was about the using traces for trace-driven development. So we want to do an experiment together with Gabriel the thing that we want to do is that we run, as you develop a model, dynamically you write things, you add them, all the things that you see on your screen, all the things that you try, they should be recorded, and the test should be generated to check if the things that you saw are still the way that you saw them. That's the way that I imagine it. I cannot tell you more because we did not try it yet because the tool is still under development, but as we do, we will have the first experiment. We will hopefully present it on next ESUG.
Hello. I wanted to ask which kind of files are you serializing now for models? Because, for example, any logic, gamma, other repast using project-based files. What kind of if you need to serialize also resources like images or other assets for a model, how are you planning to implement that?
That's a very good question, thank you. So in fact, originally what we were doing, what Cormas was doing, is serializing a model into a certain kind of file and keeping track of the version of this file, author of this file. But then we saw that this is kind of conflicting with GitHub because we're also saving models on GitHub. And like this, Git is making versioning and also Cormas is making its own versioning. It was really hard to manage. So right now we only use Git to version models and to save them. So we save models as simple Pharo code, as simple Pharo classes. They're saved on your Pharo image. And then if you want to share them with people, you upload them on GitHub and you send them the link. And they use them. On the other hand, we see that it's really important to have some kind of serialization, because even though in our community here we can easily use GitHub, we can easily understand Git, in modeling community it's not always the case, and people really need some kind of file that they can just drag and drop and open, double click on it. So we will think of it. It's not, currently we don't have the serialization that is working, but we need to come back to that question. Thank you.
Thank you.
No other questions?
Thank you.